Welcome back to Jules Matos. Our session today, we are focusing on calculating our unlike fractions with different denominators. And in this session, I am working with three fractions and we will be applying our cross multiplication, or what is better known as the butterfly method, to our question. So if you're ready to see how to calculate your unlike fractions with the butterfly method, let's get started. So we will be using our cross multiplication for this session, and usually when applying the cross multiplication, this step usually only applies to two fractions. Now in cases when there are three or more fractions, we usually use the LCD method because it allows us to find the common denominator for all of our fractions in one setting. Now, when we are applying the butterfly method, like I stated earlier, because this only applies to two fractions, that means for this question, I will have to calculate two fractions at a time and then add the third one on after I found their sum. So let's get started. Now, because we are working with addition and all of our fractions denominators are different, that means that you can decide to start with any two fractions that you choose. Now, since I'm working through this question, I will begin with the first two questions in my equation. So I will begin calculating 2/3, and I'm adding that to 3/4. Now remember that with our cross multiplication, that means that I'm multiplying my numerator of 2 to the denominator of 4. So I'm multiplying 2 times 4, which is equal to 8. So 8 would be the numerator in my new fraction. And then we are now going to be applying that same step to our next fraction, where I will now multiply the denominator of my first fraction, which is 3, to my numerator in the second fraction, which is also 3. So I'm multiplying 3 times 3, which will equal to 9. So 9 would now be my new numerator in the second fraction. And to find our common denominator, we're going to be multiplying our numbers of 3 and 4 together. So I'm multiplying 3 times 4, which is equal to 12. So my new denominator for both of my fractions will equal to 12. So now that I have found my LCD, and I've converted my fractions to their equivalent form, I'm now going to begin the addition process. So I will be adding 8 plus 9, which will equal to 17. And my denominators, since they're alike, will remain the same. Now at this step, you can decide to keep your fraction the same and work with it as an improper fraction, or you can decide if you want to simplify your question now instead of waiting at the end. You can do that as well. So what I'm going to do is, since I have an improper fraction, I'm going to convert this fraction into a mixed fraction. And my mixed fraction will be 1 whole and 5/12. So now that I've converted my fraction into its mixed fraction form, I'm now going to take my second step, because I still have another fraction left, and I'm going to take my 1 whole and 5/12, and this will be added to my final fraction in my question, which is 2/5. Now what I'm going to do is, for this question, instead of focusing on my 1 whole, I will leave that out for now and just focus on my fractions and then add the 1 whole back to my answer at the end. So let's begin our cross multiplication. So I'm multiplying my fraction, my numerator of 5 times my denominator of 5. So I'll be multiplying 5 times 5, which will equal to 25. And I'm now going to apply the same thing to the next half my fraction, where we will be multiplying our denominator of 12 times our numerator of 2. So we're multiplying 12 times 2, which is equal to 24. And then to find our LCD, we will be multiplying our denominators of 12 and 5. So we're multiplying 12 times 5, which will equal to 60. So both of my denominators will equal to 60. And remember, I haven't forgotten my 1 whole. I will be adding that back in my final solution. So we're now going to add our numerators. And when 25 is added to 24, that will equal to 49. So my final solution for my fraction will equal to 1 whole and 49/60. Okay, so there you have it. We just calculate the sum of our fractions using our cross multiplication when we have three fractions involved. And remember that if you are using cross multiplication and you have three or more fractions involved, you will have to do the cross multiplication step for every two fractions. So that means that if we were working with four fractions, then after I would have gotten my sum in the second fraction, I would have had to apply the cross multiplication step again to the fourth final fraction in order to get my solution. So even though the cross multiplication is an easy process to remember and it does help you find the LCD quicker, remember that finding the LCD for your fraction can also help you to work through this step a lot easier. So it's good to know the cross multiplication and the LCD method because both of them have their purpose when we're working out our sum and differences of our fractions. So as always, make sure you get some additional practice in, and I'll see you right here in the next video on Jules Math Tools, where the goal is to make math easy.